Hi friends, welcome to my channel. Today we are going to continue the data structures part 2. If anyone didn't watch it the part 1, please go to the part 1 and please have a look at it. Have a look at that so that we'll get a brief note. In the part 1 we have discussed about the algorithm for traversing, that means visiting each element of an array, and now we are going to discuss about the algorithm for insertion. Now without getting into the insertion concept algorithm, just have a brief look of how insertion is performed in an array in theoretical approach. Let us take an array A which starts from index 0, 1, 2. Let us assume it only for 6. So the index is 7. because it starts from 0 to n minus 1. So the elements are from 0 to 6. Now I am going to insert 1 in this array, in this particular array. Let us assume 3, 4, 7, 6, 8, 9. So it starts from, okay. Now it starts from index 0 to 6, total 7 elements. So in order to insert in somewhere like in between these 6 and 8, I have to know a position where it should be inserted, and position should be noted. Item which we want to be inserted, like where to insert, what to insert. That's why position, nothing but where to insert. Item, nothing but what to insert. Array is nothing but what we considered here as a array. N is nothing but an index of array. Now, how insertion is performed here? The position should be noted. What should be added at that particular location? Item should be noted. So, now I am adding here 7 at a particular location. This one. Position is 4 and the item which I am going to insert is 7 in this particular location. So now let us come to the algorithm. We have to start a step, look at this condition. First we have to check this condition. If this condition satisfies, then only we will go to the next steps. Okay. Insertion is performed in 3 ways. Either we'll perform insertion at the front end or at the back end or in between elements. So we are going to check whether this entire array is greater than or equal to the position which I am going to insert or not. Now the I is equal to 7. 7 is greater than or equals to position which I take it is 4. This condition satisfies only, it will go to the next steps. Like I am going to insert here, so that I have to move this blocks to the next step. So the I position is incremented plus 1. This should be performed for entire array. Now at the particular position, I am going to insert the element which I have wanted. After inserting the element, n should be incremented, and then we have to stop the algorithm because of insertion is completed. First of all, we are going to check the number of elements in an array, and then we have to initialize the number to I. Then we have to check the condition whether the array is greater than or equal to position or not. Then we are going to add the element at a particular position, the item which to be added to be noted. After insertion, it should be performed to entire row to move the elements in an array. After insertion, we'll go to stop. Similarly, deletion is also performed. Like a simple modifications is there. Algorithm for deletion. Deletion also we have to note the position, which position, at what position the deletion should be performed, which item to be deleted, and an array should be given, and the index of an array should be specified. at the particular if the item matches a particular position, like in an array, I wanted to delete the element 2. Then the position of 2 is a of 1. If this position matches with the element I wanted to delete, then it will delete this particular element by performing the following steps. First of all, in order to do any operations in an array, we have to take a loop because it is a continuous elements in a track. So we are taking the for loop from the position which I wanted to entire array. Then the similar operations like insertion. Here I have performed like this one is incremented, right? We are going to enhance this chain. So in order to enhance the chain, we are going to increase the number. So instead of I, we have taken I plus 1. Now we are going to delete the item. Instead of I plus 1, we have taken I. That means we are decrementing an element. Similar operations in the insertion. If there is a plus, here we'll get minus. If there is minus, we'll get plus. Similar operations for algorithm of insertion. Now coming to the algorithm of sorting. Sorting. What is sorting? Sorting is nothing but arranging the elements in a particular order, that is either in ascending order or in descending order. What is ascending order? We have to sort the elements in a particular way such that the first element is the smallest element of the entire array. Descending order is quite opposite to the ascending order. Now let me explain the sorting with the help of example. Like this is the particular array which I had taken. Indexes are from 0 to 4. Entire 5 elements are there. I am going to sort in ascending order and descending order. For ascending order, I am going to compare the second element with the first element. 5 is greater than 3. But ascending order means smallest should come first. So there is no swap. Now the elements remain same. Now I am going to check the second element with the first element. Then the second element is less than the first element. So I am going to swap these two elements. So the order becomes 3, 4 and 5. Now the position of second element is 5. And 5 is going to compare with third position element, that is 2. 5 is greater than 2. So I have to get the smallest number here. So these two should be here. And then 5 comes here. Now these two will perform sorting. Which is the highest number? 9 is the highest number, so it should be at the end. And now these will again perform sorting. Now I'll compare these two. This 2 is correct. These 2 is performed. Then 2 should be swapped here. And again 2 is performed 3. So 2, 3, 4, 5, 9 is the order for sorting of algorithm in ascending order. In order to sort in descending order, the output is 9, 5, 4, 3 and 2, which is reverse of ascending order. Now let us get into the algorithm of sorting. That is, we have to check from lower bound to upper bound. That means ith position starts with lower bound. J means that which I am going to compare the second element to be noted is J. That means lower bound plus 1 to upper bound. If this position is greater than this, now I am going to swap these two elements like which I had explained here. If not, I am not going to swap. Else no swap. Stop. This is about sorting. Then I am going to explain about searching. Searching means what? Whether the element is present in that array or not. If the element is present in that array, then found is 1. Let me explain the algorithm of searching with an example. Let us take an array like this. Lower bound starts with the element 3 and upper bound end with an element 1. Indexes are 0 to 5. And the total elements in this is 6. Found means, let us take an example like element to be founded is 4. 4 is present at a location of 2 in the index 2. If in this entire array the element to be founded matches with a particular element in an array, then found equals to 1, location equals to 1. If not, the element which I have to found here is 10. Let us take an example. The element to be founded is 10. 10 is not present in an entire array. So found equals to 0, location equals to 0. This is what the algorithm is about. Searching whether the element is present in it or not. Same thing here also. Location is initially 0, found is initially 0. I is assigned from lower bound. Then I am going to check each and every element of an array. Found equals to 0. Then if the element to be founded matches with the element in an array, then found gets 1, location gets 1. Else I gets increased to search the next elements. This is the algorithm for searching. I hope you understand this concept. Now we are going to some more interesting concepts like asymptotic notations. Before getting into asymptotic notations directly, let me tell you something which makes a lot of difference, like performance. How can someone measure whether you are a good student or not? Because of your grades. How can I say she's a very good person? She studies well. How can I say someone like that? Because of their performance, efficiency in what they are doing. Like if she performed very well in the examinations and got 95%, then I'll say her performance is very high than compared to other students. How can I judge performance in computer? Time complexity and space complexity. These are the two types of performance. How can I measure the performance with time and space complexity? You may ask like that. Because time complexity is nothing but how much time it is taking to compile a program and execute it without any errors is nothing but a time complexity. Space complexity means how much memory is it taking to save the entire code inside the memory is nothing but a space complexity. Time complexity is of 3 types: best time complexity, best case, worst case, average case. Similarly in the space complexity, best case, average case, worst case. Time complexity, best case is nothing but minimum time it is taking to compile and execute everything of a program is nothing but a best case. Worst case is entire opposite to the best case because it takes the maximum time. Average time complexity is nothing but average time required to complete a program without any errors is nothing but an average time complexity. Now, the best case for space complexity is nothing but similar to the time because best case occupies a few bytes inside the memory. Like how come I say this? Minimum amount of computer memory required to store an executed program is nothing but best case for space complexity. For average case, average amount of computer memory required to store an executed program. Worst case, it takes the maximum space in the memory to save the errorless code. Let me explain this performance based on an example clearly. Let me tell you an example like an array. Now the example is I have taken an array of an index 9. So it is from 0 to 8. Key is nothing but what I have to search inside an array to be searched simply. Like a best case, I'll tell you what is best case, average case, and worst case. Best is nothing but the key to be searched. That means a key value is taken as 10, for example. It matches with the first element of an array. Key, the element to be searched, matches with the first element of an array. That means u of 0 double equals to key. This satisfied. That's why it takes a few moments of time, few moments of memory. That's why it is taken as best case. For example, the key number which I am going to search is taken as 5. I am going to check with the first element a of 0 double equals to key or not. It doesn't satisfy because the key element is 5. Doesn't satisfy. And then I will go to the first position. I will check the element with this. 30 is not equals to 5. So it doesn't satisfy. 20 is not equals to 5. Doesn't satisfy. 70 is not equals to 5. Doesn't satisfy. And then 5 is double equals to 5. Gets satisfied. This is the average complexity. Let the key which I am going to search is taken as 2. Now, in order to know whether it is a best case, average case, or worst case, we have to search the entire array. Let's start with 0th index. If 0th index is double equals to key, then it is best case. If the middle element or something nearer to the 5th or 6th element is equals to key, then it is average one. If the entire last one or if the entire last element of an array matches with the key, then it is a worst case because it takes the entire space and entire time. It's all waste. That's why we consider this as an worst case. Or else we don't even find this key in the given array. It also comes under worst case only. Now I'm going to check the 0th element matches with the key or not. 0th element is nothing but 10. 10 doesn't equals to 2. So it doesn't follows. Wrong. Of 1, 30. 30 is not equals to 2. A of 2, nothing but 20. 20 is not equals to 2. 70 is not equals to 2. A of 4, 5. 5 is not equals to 2. 4 is not equals to 2. 3 is not equals to 2. 1 is not equals to 2. Finally, 2 is equals to 2. Here it is satisfied. So it takes the entire time and entire memory. It's nothing but a worst case. Let's have a look at this example once again. This is all about the performance. Performance is of two types: time complexity, space complexity. This has three cases: best, worst, and average. This is the example for this performance. Now we are going to the next concept of asymptotic notations. So what is asymptotic notation? Asymptotic notation, it is nothing but they are mathematical formulas, like they are used to judge the time complexity and also space complexity of a program. Asymptotic notations or mathematical definitions which are used to judge space and time complexities of a program. Now, asymptotic notations is of four types. There are big O, big omega, big theta, little o. Big O. Big O is used to define the time complexity. That means it is used to find out the upper bound values of an algorithm, which are asymptotically tight values. So this is nothing but a worst case complexity of an element. We are going to find out the worst case complexities of an element using big O. Let us explain the big O with an example. Before that, we are going to have a just look at definition. F of n and g of n are two non-negative functions. We are going to prove that f of n is equals to big O of g of n if there are constant values. Then this condition works and n naught is greater than or equals to n is the output of that solution question. Now we are going to prove this big O notation with an example. Let us take an example. F of n equals to 3 of n plus 2. We are going to prove that f of n is equals to big O of g of n. Then I am going to take g of n equals to n and the constant values as 5. Let it be. We are going to check each and every condition. This is the condition of f of n. If it is a big O of g of n, into g of n. Now the c value is already given as 5. G of n is already here. It is n. Now we are going to check each and every possibilities for this. Now the n value is taken as 1. I am going to put 1 in f of n equation. That is 3 into n plus 2, which is f of n. Nothing but 5. 5 is less than or equals to c. 5 into g of n is nothing but n, which is 1 here. 5 into 1, that is 5. 5 is less than or equals to 5. Condition satisfied. Then I am going to take the n value as 2. Then I am going to check again. F of n equals to 3n plus 2. That means 3 into 2 plus 2, 8. 8 is less than or equals to 5 into n. N is nothing but 2. 10. This is also satisfied. I have to check the entire values for this. I had to check, or else I will take this as n naught is greater than or equal to n for all, because it satisfies the condition from n equal to 1, n equal to 2, n equal to 3, and so on up to n. This is how we have to check the big O representation for a given question. This is the graphical representation for big O asymptotic notation. Let's have a brief look at it. Tomorrow we are going to discuss further concepts other than this big O concept. I hope you liked this video. If you enjoyed this video, give a big thumbs up, share, and also subscribe to my channel. Thanks for watching.